Good morning, Algebra Scholars. Today we're going to talk about section 9.4, only certain parts. We're not going to do the entire unit, but I did want to explain to you how a sine function actually looks on the Cartesian coordinate, as well as explain the parts so that you know what it is we're going to be doing. So if you start with this website, if you'd like to go and look at the very beginning, it shows a GIF on how you can take a unit circle and basically turn it into a sine wave. Go ahead and take a minute to do that now. Now, if I have a unit circle, we know that this point is 1, 0. This point is 0, 1. Here it's negative 1, 0. And here it's 0, negative 1. That's our basic unit circle. Say I want to look at the sine values only. Remember, sine is associated with y. Well, if I was going to look at, let's say, radians, this is 0 radians. This is pi over 2 radians, pi radians, and 3 pi over 2 radians. So let's say I was going to take that and I was going to put it on this graph here. Say if I could label this 0, 1, 2, 3, 4, and I could label this pi. I could label this 2 pi, and of course the halves will be in the middle. Okay. Then if I drew the corresponding points along a graph, at 0, the sine value is 0. At pi over 2, I should mark these two. Let's see. I'm going to call this 1. 1, 2, 3, 4. And I'm going to call this one negative 1. So at 0, sine is 0. At pi, sine is 0. At pi over 2, sine is 1. At 3 pi over 2, sine is negative 1. And at 2 pi, it again goes up like this. Then it's going to repeat itself. Starts at 0, goes up, goes to 0, goes down. Goes up to 0, goes up, goes to 0, goes down. So what you're really looking at is this nice curve that we call a wave. Okay, so we know from here it goes up, and then it's going to come down, and it goes down, and it just continues on ad infinitum, and of course it'll go the other direction too. It's just that we only drew these. And this is called the sine wave. So this is y equals sine x. Of course, you can do it in degrees also. There's a couple things we're going to label. We're going to talk about this line right here that goes directly in the middle as a center line or a midline. We're going to talk about this distance from the center line to the top, or what's called the crest, and also it's the same distance to the bottom, which is called the trough. That is called amplitude, and it repeats itself over and over. So what we're really looking at here, for one cycle goes from 0 to 2 pi. In other words, it has to go exactly to the same place. And that is called a period. A period could also go, say, from here to here, from a crest to a crest, or trough to a trough, just as long as it completely repeats all the way through one cycle. So we're going to do some vocabulary on the next page. We're going to work on, there is a parent function. Of course, there's transformations we can do to this, but this is basically what it looks like. So I want you to go back to that website now, Math is Fun. Take a look at those, and I'll keep going on to the next slide. This shows the GIF that is on that page, and I went ahead and labeled it. And if you can see how these points here, where the triangle's going around the circle, correspond to the Cartesian coordinate on the left, you'll see where it comes from. You can graph all of the trig functions that we've been working on. We're only going to work on sine because we have a limited number of days left, but all of them will be similar, especially cosine and sine look a lot the same. This next page that I have is page 257 in your student journal. If we were in the classroom together, or if we were on a live meeting, I would actually have you take out your unit circle paper foldable, paper takeaway thing, and I would have you fill in these values. Then when you plot them down here, you're basically doing exactly the same thing I did on the previous slide, as well as the GIF from the Math is Fun page. And it's kind of neat to do it yourself, okay, because we're not in the classroom at this time. We're not going to do that. The next page, you may notice that it's going to do cosine. So I put the slide in here, but we're not actually going to do this one. So moving on to page 259, you'll notice that there's space for the notes. We've talked about amplitude. A periodic function is a function that repeats in periods. And you can see it has a repeating pattern right here. It tells you exactly what that is. A cycle is the shortest repeating portion, okay, of the graph. That's one cycle. The horizontal length is called a period, and the graph has a period of 2 pi. So our range is always going to be -1 to 1. The domain is everything, okay, so all real numbers. And the x-intercepts and the y-intercepts for cosine. So pretty much where it crosses the x-axis. Make sure you look at that in your journal. Page 259, write down those notes. And then there is a specific way to figure out each one of these graphs. That's what we're going to be moving on to next. You can consider them transformations. But for our first day of practice, this is all it is. It's just going to learn the vocabulary and see what it is. And then I'll move on. So the parts of a sine function can be identified simply by looking at the equation. A basic sine wave can be multiplied to go higher and lower by the amplitude. And that's going to be the number that is in front of the sine. So we call it A. B is going to affect how bouncy it is, how long or how short it's going to be. And so B is going to affect your period, which actually comes from here. H is going to be a shift, and that will be along the x-axis. So this is going to be a horizontal shift, and you may be able to guess that K, because it's out there like the Y, is a vertical shift. So K is going to change your midline. It will either move the entire graph up or the entire graph down. So that's why we have them marked A, B, H, and K. So this is your basic function right here. This is your parent function. And what we're going to do is simply identify the parts. And we have, if you want to take a look at the extra practice on the next page, we'll go through each one and just figure out what they are. So just as an example, on number 1, page 261 for the student journal, there is no number in front of your sign. So here, A is 1. And because the 2 is directly in front of the X, then B is 2. So your period is 2 pi divided by 2, which means your period is only pi. And I got those numbers from up here. Number 2, A, you'll notice, is 1/3. That's the number in front. And if I were looking at this, my period would be exactly the same for cosine. P is 2 pi over 2, and so that's pi. If I was going to look at number 3, it's going to be slightly different. So A is 4. That's all you have to do is identify it. But here, the number in front of X is 2 pi. So B is 2 pi for number 3, which means it has a period of just 1, whatever those are. For 4, if you were going to do the same thing here, A is 1/2. It's the number in front. The period is 2 pi over B, and here B is 3 pi, which means it reduces to 2 over 3. Same thing on 5 and 6. If you were just going to identify what the period is, you take the number B in front, and you take the number A in front. So here A is 1, B is 1/2. For number 6, A is 1, B is 1. So that should be enough to get you started, especially on the puzzle time that is assigned for today. And then for tomorrow, we will simply do those graphs that are right here, but we'll get to that in a minute. For today, all you need to do is identify the amplitude and the period and do the puzzle time. So see you tomorrow.